So another limiting reagent question, this one involving actually one of the most important chemical reactions on Earth, respiration, the process by which cells turn sugar, which is C6H12O6, technically it's glucose, and they take oxygen, they turn that into carbon dioxide, water, but most importantly energy. That's how you and I take food and go about our day. What we know is we have 25 grams of glucose, we have 40 grams of oxygen, and the question is a little bit different this time. We want to know what mass of carbon dioxide forms. So it complicates the question a little bit, but we still know that we have some sugar, we have some oxygen, one of which will get all used up, one of which won't. We need to figure out which one does. So if we deal with the glucose, we need to know how many moles of it we have. So to do that, we find the molar mass, which is slightly more complicated. It's a larger molecule. We have 6 carbons, each weighing 12.011, totals up to 72.066. We have 12 hydrogens at 1.008, totals to 12.096. And we have 6 oxygens at 15.999, giving us 95.994. Adding that all together gives us a molar mass of 180.156 grams per mole. The number of moles is always mass divided by molar mass, so 25 divided by 180.156, which gives us 0.13877 moles of sugar, which I'm going to fill in up at the top. Oxygen is the other substance. We need to know how many moles of it we have. Molar mass of oxygen, slightly easier. We only have 2 oxygens at 15.999, so 31.998 grams per mole. The number of moles of oxygen, mass 40 grams divided by molar mass 31.998, gives us 0.125, 1.2501 moles of oxygen. Now here is where we need to make an assumption, and we need to assume that one of these is our limiting reagent. Again, it doesn't matter which one. I'm going to pick the sugar. And again, it does not matter which one you assume, because we'll go through both scenarios where the assumption is false, like on example 1. And there will be examples where the assumption is true. So what we know is that we have 0.13877 moles of glucose. We need to multiply that by the mole ratio, looking back at the chemical equation. 1 mole of glucose, and we're dealing with oxygen as the other substance, 6 moles of O2. So mole ratio will have 6 moles of O2 and 1 mole of glucose. Do that calculation, we get 0.83262 moles of O2 that is needed. So taking a look back at how much oxygen we actually have 1.25 moles of oxygen. So we actually have excess oxygen. So what we know then is that C6H12O6 is the limiting reagent. We have 1.25 moles of oxygen, but we only need 0.83. So we have more than enough oxygen, so sugar is what gets all used up. And at this point, this is where the question changes a little bit. What mass of carbon dioxide forms? Well, it doesn't matter anymore how much oxygen we had present in this reaction, because not all of it gets used up. All that matters now is the substance that does get all used up, which is the sugar. Now this turns into a simple stoichiometry problem. We actually use the whole amount of sugar, 0.13877 moles of it. And the question now is how much CO2 is produced. Well, we already know how many moles of sugar we used. We're basically on step 2 of a standard stoichiometry problem. So, knowing that we use up 0.13877 moles of sugar, we can multiply that by the mole ratio of sugar and CO2 to determine how much CO2 gets produced. So going back, again, sugar was 1 mole, CO2 is 6. So multiply by 6 moles CO2 over 1 mole C6H12O6. Tells us that we actually produced 0.83262 moles of CO2. Now we know how many moles of CO2, can find the mass quite easily. We need to find the molar mass of CO2, which was 1 carbon, weighing 12.011. 2 oxygens, each weighing 15.999, gives us 31.998. Total that up to 44.009 grams per mole is the molar mass of CO2. Now we know the molar mass of CO2, we can find its mass. Mass equals moles times molar mass, so we have 0.83262 moles. Multiply that by the molar mass of 44.009, which will give us 36.6 grams of CO2.